Welcome guys. Um, this is Joel and from Gem Tutorials. Today I'm bringing you a lesson of mathematics. So as you can see from the board, I've written your favorite topic there. So today we'll be covering trigonometry. This first session, guys, of trigonometry, I'll be including revision from grade 10 and grade 11, but please do not undermine it, but because you will need it in your grade 12 questions. So please guys, do invite others to watch this video by sharing the link. Leave your comments on the comment section. Please don't forget to hit that subscribe button. That will be very much appreciated by us. So without wasting any time, guys, I'm just going to shoot right away. Trigonometry, guys, the word trigonometry means the measurement of triangles. So in trigonometry, we'll be talking about measurement of triangles. Basically, trigonometry expresses the relationship between the angle of a triangle and the sides of a triangle. So in trigonometry, we are going to be talking about the relationship between the angles and sides of a triangle. So the triangle we are going to be specifically talking about in trigonometry is a right angled triangle, guys, a right angled triangle. So in a right angled triangle, you can use the trig ratios which we learned in grade 10 and in grade 11. So in grade 10 and grade 11, we were introduced to the basic trigonometry, where we're having three trigonometric ratios, guys. The first one being sine of an angle. I'm just going to say theta as my angle, which was said to be equal to the opposite side, guys, divided by the hypotenuse side. Coming to the second trig ratio, which was cos theta, cos of an angle, which is calculated by the adjacent side divided by the hypotenuse of a triangle, guys. The last one being tan of an angle being calculated by the opposite side divided by the adjacent side. So I just want to make an illustration about the opposite, the adjacent and the hypotenuse side. Say for instance I had that triangle ABC. So my triangle ABC is a right angled triangle. So I want you to note one thing, guys. So the side which is opposite the 90 degrees angle will always be what we call the hypotenuse side. So the side opposite the 90 degrees is always called the hypotenuse. So the hypotenuse side on those trig ratios stands for the side opposite the right angled triangle. Now the opposite side and the adjacent side, guys, depend. They all depend on which angle you are talking about. Say for instance I was looking at angle A. If I were to look at the angle which is opposite my angle, if I were to look at the side that was opposite angle A, the side opposite angle A in this case would be BC. But if I were to look at the adjacent side, remember we've already labeled that side as the hypotenuse. We are saying now this side is the opposite side of that angle A, to mean that this third side will be the adjacent side. So if I were to write the expression of my sine of theta there, my sine of theta is equal to the opposite side divided by the hypotenuse. This time let me not say my sine of theta, let me say my sine of angle A. I'm specifically referring to angle A now, guys. So which side is opposite my angle A? We said it is BC, which side is my hypotenuse? We had already said it is AC, so that would be the expression of my sine of A. If we move to my expression of cos of A, we said cos is given by the adjacent side divided by the hypotenuse. So we said our adjacent side here is AB over our hypotenuse, which is AC. Coming to tan of angle A, tan of angle A is given by the opposite side. Which side is opposite that angle, guys? It is BC divided by which side is adjacent to angle A? It is actually AB. So those were expressions you would have to make about that angle. Now let's change this a little bit. I'm also considering my triangle ABC, having my B there being equal to 90 degrees. Remember, we said the side which is opposite the 90 degrees is always the hypotenuse side. Now let's talk about angle C. If we were to look at angle C, which side is opposite angle C? You can see that the opposite side is actually AB, so I'm just going to label that opposite, and obvious my BC is my adjacent side. So once again, if we were to make an expression of sine of angle C, remember it is opposite side over the hypotenuse, so my opposite side this time is actually AB divided by my hypotenuse, which is still AC. If I were to make my expression of cos of angle C, I'd have to take the side which is adjacent to angle C, which is BC, and divide it by my hypotenuse still, which is AC. Also moving to tan of angle C. Tan is given by the opposite side. Remember, we said our opposite side was AB divided by our adjacent side. So our adjacent side was BC. So you have to be flexible as to how to apply these three trig ratios on different triangles you are given. But guys, it is true that the definitions are given on the board can be changed slightly different when your triangle is placed on a Cartesian plane. So let's look at a triangle plotted on a Cartesian plane. Say for instance, I'm having a Cartesian plane there, and I'm having triangle OA, let's say C, and I'm given that that angle is actually equal to 90 degrees. On a normal basis, it is not usually drawn on the Cartesian plane, but when it is drawn, when that triangle is drawn on a Cartesian plane, you know that this side it represents the x-axis. So my OC would be giving me my x there. My OA, remember we said the side opposite the 90 degrees is the hypotenuse. And my O and my AC is actually represented by my Y. So in other cases, that can only be drawn like that. It can be drawn only like that. X is to Y. So you have to know that your OA there is your hypotenuse. But you can also extend it so that this can be your Y and that could be your X. Let's see how these definitions change. As I have said, when we come to the Cartesian plane, guys, our sine of an angle, whatever angle, will be given as y over r, r being my hypotenuse side. So I'm just going to erase that hypotenuse and label it with r, also with r there. So my r is my hypotenuse side. Coming to the definition of cos of an angle, it will be equal to my x over r. My x is the value of x at a there. If your x is negative, you have to substitute the negative value of x, but we'll come to that. Coming to my tan of whatever angle, guys, my tan of an angle will be given by y over x. So you have to learn these definitions, guys, both for a triangle plotted on a Cartesian plane and a triangle not placed on a Cartesian plane. So also moving, guys, to the second part of grade 10 and 11 revision. You were given maybe something like, let's say triangle ABC once more. And let's say my angle C, there is actually theta, and I'm given that my AB is 2, and maybe my BC, let's say my AC is 3. And they asked me to calculate the value of my theta there. Remember, we said trigonometry is the relationship between the angles of a triangle and the side of a triangle. We express that relationship, guys, using the 3 trig ratios we've just talked about. So if you were to express, guys, the relationship between this angle and the 2 sides that you are given, which trig ratio would you use? So in order for you to be able to answer that, you'd have to look at the angle you are asked to calculate. Which side are you given? You are given the side which is opposite to that angle. You are also given the side opposite 90 degrees, which we said must be the hypotenuse. So you are having the opposite side now and the hypotenuse for that angle. How would you go about now to calculate that angle? Since I'm having an opposite side and the hypotenuse, I can see that I can use my trig ratio of sine of theta. Theta is that angle. So what is sine of theta? It is actually equal to opposite over the hypotenuse side. So substituting my opposite, I'm writing that sine of theta is equal to my opposite side is 2, my hypotenuse is 3. Then how do you solve for this theta? You invert your sign. Theta will be equal to the inverse of sine 2 over 3. You should know how to punch this on a calculator. You just press shift and press sign. It will automatically appear. Let's move to another example, guys. Say for instance I was given now a triangle of that nature. Let's say that is my 90 degrees, so that I'm having AJ, K, and they tell me that my K is beta, guys. Now if I'm given beta and I'm given that my AJ is 4 units and I'm given that JK is actually 6 units, they asked me once more to find the magnitude or the size of that angle beta. So remember, this is trigonometry. You need to find a trig ratio that expresses the relationship between this angle and the 2 sides that you are given. This side, which is JK, is actually the hypotenuse side because it is opposite 90 degrees. Now looking at that angle, we could say AJ is the adjacent side. So which trig ratio combines the adjacent side and the hypotenuse side? I think we are all agreeing with me that it is cos. So cos of that angle, which is beta, is given by the adjacent side divided by the hypotenuse side. Further simplifying, I'm just going to substitute in the place of my adjacent side. It is 4 divided by my hypotenuse side, which is 6. Now also transposing that cos there to make its inverse, I'm going to have beta is the cos inverse of 4 over 6. Then you punch your calculator, guys. I'm not going to be writing the final values. You should have written your final value of theta as an angle. For instance, if the answer here was 25,4 degrees, we would say therefore your theta is 25,4 degrees, and the same applies in that one. I hope guys you got the idea. At times you may be given the opposite and the adjacent side. In that case, you are going to be required to use the tan trig ratio. It is actually called the tangent in full, but we say it is tan, and the cos is the cosine, but we say it is cos. Now let's move to another thing, guys. What they would like to do in this topic is to mix triangles with Cartesian planes, guys. So we better get comfortable with our Cartesian planes before we move. There's a dynamic which you can use if you ever forget the value of your trig ratios, which is written as soccer TOA. So it says the S stands for sine. It means that sine of an angle is equal to the opposite side divided by hypotenuse. So that is my SO. Coming to this CAH, it means that my cos of an angle is equal to the adjacent side divided by the hypotenuse side. And lastly, that TOA, it means that my tan is equal to my opposite side over my adjacent side. So that is actually a good dynamic that can remind you of these three trig ratios. So I wanted now to move to, I want us to now talk more about the Cartesian plane. Let's first talk about the axis of the Cartesian plane. We are having the x-axis as the horizontal line and the y-axis as the vertical line. From 0 to the right, your x is positive there, and from 0 to the upwards, you are having your y as positive. The opposite is true. From 0 vertically downwards, you are having your y as negative, and from 0 to the left, you are having your x as negative. So if you were to look at this quadrant, this is the first quadrant, guys. This is the second quadrant. This is the third quadrant, and this is the fourth quadrant. So we are going to be talking about quadrants of a Cartesian plane. So if you were to look at our first quadrant, guys, we'd realize that our x is actually positive and our y is actually positive. Moving to the second quadrant, our x is negative and our y is actually positive. To the third, our x is negative and our y is positive. And lastly, to our fourth quadrant, our x there is positive and our y is negative. Now I want us guys to be familiar with the signs of the trig ratios in different quadrants. I'm going to add in all of these my hypotenuse, which is expressed as r from Pythagoras theorem. We are going to cover Pythagoras theorem in a little bit while. So my hypotenuse, guys, is a length of a line. So our x here could be a coordinate, as I've shown to you. I've showed you that it can be given as this, given x is to y. So x is to y are actually coordinates. But when we come to my r is actually the length. It is the hypotenuse. So mathematically, or to make sense of it, any length, guys, can never be negative. So in all four quadrants, we are going to be having our hypotenuse side being positive, guys. So now if we were to look also at that first quadrant, let me just move. Let me draw another Cartesian plane that will go in conjunction with this one. This is y, this is x. If we are, guys, to write the expression of the three trig ratios in quadrant 1, we know that our sine of an angle is given by y over r. So if we were to look at quadrant 1, I'm having my y as being positive and my r is always positive. So my sine of an angle in the first quadrant will be positive. Sine of any angle is positive on the first quadrant. Coming to cos, guys, of any angle in the first quadrant. Cos of any angle is given by x over r, and my x in the first quadrant is actually positive. Also, my hypotenuse is always positive, so you can see that your cos theta is actually having a positive value, guys. Cos of an angle. Also, now moving to tan of an angle. Tan of any angle is given by y over x. If I look at my first quadrant, I can see that my y is actually positive and my x. So I'm also getting the positive value of what? Of tan in the first quadrant. So you can see that in the first quadrant, all your trig ratios are positive, guys. I'm not going to do all this for the remaining quadrants, guys. I'm just going to write the signs of the quadrants, sort of the trig ratios in the quadrants. But if I can just make an example. If you look at second quadrant, remember we said in second quadrant we're having our y as positive and our r as positive and our x as negative. If I were to calculate my sine of any angle in my first quadrant, I'm having my positive y once more and my positive r. You can see that I'm also going to have a positive sine of any angle. But if I look at my cos and my tan, guys, since my x is negative in the second quadrant, if I divide any negative number by a positive number, I will get a negative. So my cos is negative in the second quadrant and my tan is also negative. Moving on to third quadrant, I'm going to be having my sine as negative there and also my cos as negative. And lastly, my tan will be positive on that quadrant. You can prove it using this method. Moving to the last quadrant, which is the fourth, I'm having my sine there also as negative. I'm having my cos there actually being positive, and I'm having my tan as negative. So you are going to have to memorize all these, guys. That in the first quadrant, all my quadrants, so all my trig ratios are actually positive. In the second quadrant, my sine is the only positive ratio. So the diagram that will help you memorize this, guys, is actually a nice mnemonic. It's written this way. Some call it the cast diagram. Cast diagram, cast, C-A-S-T. So others may say all students take coffee or all students take care. I don't know how you are going to be able to memorize it, but this is how it goes. The A in the first quadrant says all trig ratios are positive. The S in the second quadrant says it's only sine which is positive in the second quadrant. So cos and tan is negative. While in the third quadrant, the T stands for it's only tan, which is only positive on the third quadrant. So my cos and my sine in my third quadrant is actually negative. Coming to the fourth quadrant, the C stands for cos is the only trig ratio which is positive in that quadrant. So I'm going to need you guys to memorize all of that. But let's go further with our Cartesian plane, guys. I'm just going to erase here in order for me to make some space. Now, if I were to label my axis once more, I'm having 0 degrees, guys, on that line. On that vertical, I'm having 90 degrees, I'm having 180 degrees, and on that angle, I'm having 270 degrees. So in the place of 0 degrees, it can also be considered that it is 360 degrees. There is one important thing I forgot to state, guys. In trigonometry, when we measure angles, we measure in an anti-clockwise direction, guys. So in an anti-clockwise direction, that is why we move from 0 to 90. Remember, anti-clockwise will be in that direction. In that direction. So we say when you move from 0 and you increase in an anti-clockwise direction, you will get to 90 and so on, 180 and 270. So you are actually going to need this, guys. You are going to be asked maybe to be given maybe a restriction that tells you about the quadrant in which the angle you are particularly talking about, in that case, lies. Let me make an example. If I'm told that my cos of x is equal to, let me say, p. I'm just making an example, guys. They are telling me that my cos of x is equal to p. And they also tell me that my x is greater than, let's say it is greater than 180 degrees but less than 360 degrees. And they ask me, in which quadrant does that x lie? So they've given me that my cos of x is equal to p, and my x lies between 180 degrees and 360 degrees. So you are going to need two things, guys, in order for you to be able to recognize the quadrant. First and foremost important is to identify the sign of your trig ratio. So I'm given there my cos of x is equal to p, and that is actually positive p, guys. So if I'm having cos of x equal to something positive, I can say my cos of x is actually positive. So there goes. From that, you are going to note that from our cast diagram, we are going to need to identify the quadrant in which cos is actually positive. Remember, we said in the first quadrant they are all positive, so cos is implicated. Another quadrant where where cos is actually positive is that quadrant where you are having C. Now you cannot decide from this only that your x lies in the first quadrant or the fourth quadrant. The second thing that is most important that will help you to identify is to know those lines, guys. We are having 90 degrees, we are having 180, 270 degrees, 360 degrees. So let's look at, they told me that my x is greater than 180 degrees. So I'm having my 180 degrees there. Any value which is greater than 180 degrees should be between this quadrant and this quadrant. So I'm having that value also being implicated, and I'm having that value also being implicated. They are telling me my x is greater than 180 degrees. Anything greater than 180 degrees, guys, is between those two quadrants. Now, they also tell me that my x is less than 360. If they tell me that my x is less than 360, they are also implicating these two quadrants. But in which one did I mark 2 times? So you can see that I marked 2 times in the place of the fourth quadrant to mean that that x lies in that quadrant. So if you were asked to draw that triangle on the Cartesian plane, you'd have to draw it on that quadrant. Remember there, the point of your coordinates, x is to y, and that being your r. Let's try another question to see if it will make sense, guys, about identifying the quadrants you have to know. Let me say this time I'm told that my sine of beta 2 sine beta minus 1 is equal to 0. And they tell me that my beta is greater than 90. Should we say 90? Yes, let me say beta is greater than 90 degrees. No, let me say it's greater than 0 degrees, but less than 180 degrees. So if you are told or you were asked to identify the quadrant in which that beta lies, this is how you would have to do it. First, you'd have to simplify, guys. Have an expression sine beta is equal to something. So I'm having 2 sine beta minus 1 is equal to 0. So if I transpose the negative 1 to that side, I'm going to have something 2 sine beta is equal to 1. Dividing both sides by 2, I'm going to have my sine beta being equal to half. So you could see that my no. I think I made a mistake here, guys. I think it can be inconclusive for that one. Let's just put plus 1, guys, there. And let's change, let's say it is greater than 90 degrees, but less than 270 degrees. There will be no solution for that. So that when we try to solve our sine of beta, we're going to transpose our positive 1 to be negative 1 and divide both sides by 2 to have sine of beta is equal to negative half. So you can actually see that my sine of beta is negative, guys. So first, identify which quadrants are in which sine of beta is negative. You can see that on the third quadrant, your sine is actually negative, and on your fourth quadrant. Now let's look at the restrictions. What are they telling me? They are telling me that my beta is greater than 90 degrees. So that is 90 degrees. Anything greater than 90 degrees should include the second quadrant, the third and the fourth. But they are telling me but less than 270. So we are having 270 degrees. So they are telling me my beta is greater than 90 but less than 270. So you could see that 2 quadrants are implicated in that. But in order for us to conclude, we look at the so we said this tells us that the second quadrant and the third quadrant is implicated. And from that, sine beta is actually equal to a negative value. We identify 2 quadrants in which sine is actually negative. So after that, you could see where I have marked it twice. This is where you are going to draw your diagram. So if I were to draw my diagram, it would be something like this and have my beta there. Now let's expand this question, guys, to how it is going to be asked. You may be given something like that. You are given that 2 sine of beta plus 1 is equal to 0, and beta is greater than 90 degrees but less than 270 degrees. And they tell you maybe to find the value of tan of beta. If they tell you to find the value of tan of beta when you are given that, this is how you are going to attempt the question. So, first and most important thing, guys, is to draw that diagram. As I've showed you how to draw the diagram, I'm not having any stress of whether you'll be able to calculate, to draw that triangle on a Cartesian plane. The second thing you have to identify is the values you are given. I have written here sine of beta is actually equal to negative half, and we know our sine is given by y over r, guys. So this means that one of the values there should be my y and one of them should be my r. Now look at the negative. I'm having negative half there. I'm not sure if the negative belongs to the y or the negative belongs to the 2. Now, if I'm not sure, I know that my R is my hypotenuse, and I did mention that, guys, your hypotenuse will always be positive. So I can conclude from there that my R is actually equal to 2 units. This means that my Y will be the one that will inherit the negative. So my Y is actually equal to -1. So in order for me to calculate tan of beta, I know that tan of beta is equal to y over x. I have the y, which is -1, but I do not have the x. Remember, this is a right-angled triangle. You are going to have to calculate the value of your x in any instance, guys. So we are going to calculate the value of x using what we call the Pythagoras theorem. So the Pythagoras theorem says x squared plus y squared should be equal to r squared. You should also write the reason there, Pythagoras theorem. So I can say that I don't have the value of my x, it's what I'm looking for, plus my y, which is actually -1 all squared, which is equal to my r squared, which is 2 squared. So if I were to solve for my x there, I would have x squared is equal to my 2 squared is 4, minus 1 squared is 1. Transposing that side, I would have 4 minus 1, which is 3. Square rooting both sides, I put plus or minus. This is another important part, guys. At the beginning, I did mention that on our third quadrant, we are having x being negative and our y being negative. So in order for you to decide the value of your x, look at the quadrant in which we are working with. In my third quadrant, I'm going to conclude that my x is -√3. I'm not sure if it is visible, but guys, x is equal to -√3. Now I can answer any question they ask me because I've got my x, I've got my y, I've got my r, I've got my diagram. Now let's see if how can we find the value of tan of beta. Finally, my y is -1, my x is -√3. So my tan of beta is actually 1/√3. They tell me to find the value of 2 sine beta minus 12 cos beta. Since I've already calculated the value of my r and my x, I'm just going to answer this question straight away. I write 2 in the place of sine of beta. I know that sine of beta should be something sine of an angle is y over r. So I know my y that it is actually -1 and my r is 2. So I've substituted in the place of sine of beta, minus 12. Now in the place of cos of beta, what is my cos of beta? My cos of beta is given by my x over r. So I've just calculated my r, so my x to be -√3. I'm just going to divide that by my hypotenuse, which is 2. They will often, guys, say do not use a calculator. So please, guys, be careful. After this step, you can use a calculator, but the way you use a calculator, you should not show that you've used a calculator. I'm not sure if that makes sense, but what I'm trying to say, guys, is to at least punch your calculator on the first part. Punch on the calculator 2 times minus half and simplify it. So I'll be having -1 there. If I punch 2 times -1 over 2, I'll have -1 and have and say punch -12 times multiplied by all this thing in the bracket. If I'm correct, you are going to be having your +6√3. Then finally use your calculator if possible, but I don't think this can be simplified further. I'm not sure because I don't have a calculator. So I hope you guys are having an idea of how to deal with such questions. I'm just going to make the second and the last example so that we can move to something. They tell me that if 13 cos of alpha plus 5 is equal to 0, and my sine of alpha my sine of alpha is greater than 0. They are telling me to find the value of 13 sine of alpha. What is this? Minus 5 tan a minus 5 tan of alpha. So this question should be worth something like 4 or 5 marks, guys. So I want you to be able to answer them. So in this in this type of question, remember we said first you need to have an expression of your trig ratio. So firstly, I'm just going to have an expression of cos of alpha is equal to something. So that is my question. Let me work it on that side. If I transpose the positive 5 to that side, it will be negative 5. So we'll have 13 cos of alpha being equal to negative 5. Dividing both sides by my 13, I'm going to have that my cos of alpha is actually equal to minus 5 over 13. Remember, cos is actually equal to x over r. So the number at the top should be my x and the number at the bottom should be my r. Now the confusing part is that negative. How do you know if the negative belongs to the x, belongs to the r? Because I said to you the r is always positive. So you know that your x is actually equal to negative 5 and your r is equal to 13. Now you always have to draw, guys, that triangle on a Cartesian plane, even if they do not tell you to do so. So I'm just going to go further, but we are not sure so far if which quadrant that alpha lies. So you can see that I'm having my cos of alpha being equal to negative 5 over 13. So I can see that my cos there is negative. So firstly, I mark all the quadrants where I'm having my cos as negative. For instance, my second quadrant, my cos is negative, and in my third. Now, they will always give you something that will help you conclude. They have told me that my sine of alpha is greater than 0. Anything greater than 0 is positive. So, which quadrant between these two has the positive value of sine? I think you could all agree with me that it is the second quadrant. So that is where you are actually going to draw your diagram now. I'm just going to draw that diagram. There I label, you're going to write your x and y. So far I'm having my x as negative 5 and I don't know my y, which means we are going to have to use Pythagoras theorem before you even attempt the question. My r is 13 units. Now let's use Pythagoras theorem to calculate the value of our y. X squared plus y squared is equal to r squared, and write the reason, guys. I'm not going to write it all. So my x is minus 5 squared plus my y, it's what I'm looking for, is equal to 13 squared. If I transpose minus 5 whole squared is actually equal to 25. So 13 squared, I'm guessing that it is 169 minus the 25, because I've transposed the 25 to that side. So I'm going to be having my y squared being equal to 169 minus 25 should be 144. If I square root both sides and put plus or minus, let's look at which quadrant are we in. We are in second quadrant. We said our y there is positive, so you conclude that your y is actually positive 12. Go back in the place of y and write 12. If you've done this, guys, you've done a lot of work. You won't be having any trouble in answering these questions. Now let's come to the exact question. They told me to find the value of that. So in the place of my 13, I write 13. In the place of my sine of alpha. What is sine, guys? Sine is given by y over r. So my y is actually 12. What is my r? It's 13. Minus 5. What is my tan of an angle, guys? It is y over x. So my y is 12. What is my x? It's actually minus 5. Again, please punch your calculator at this step and write the answer beneath, which should be 12 this time. Also punch the answer for that which I'm guessing should be positive 12, and finally write your answer to be 24. The reason why I'm saying do this, guys, because the question usually says do not use a calculator. So this is all about these types of questions. So I'm just going to touch one last which I did not actually talk about. Say for instance, I'm given that my cos of p, let's say cos of beta is equal to p. Specifically, what I'm interested there about is solving your x or your y given the trig ratio. Say for instance, I'm told that cos of beta is actually equal to p, and I'm told that my beta, let's say, is greater than 180 degrees but less than 360 degrees, and they told me maybe to calculate the value of 12 tan of beta. I'm not going to answer this question, guys, but I want to give you an idea of how you are going to answer it. First, you need to identify the quadrant in which your angle lies. So let's look at our cos of beta is actually equal to positive. So the quadrants in which cos is positive is that quadrant and that quadrant. Coming to this, they're telling me now that my beta is greater than my 180 degrees. Anything greater than 180 degrees is in that direction. Less than 360, anything less than 360 is towards that direction. So which quadrant is that, guys, in which you'd find your cos being positive? It is that lies between 180 degrees and 360 degrees. So your diagram in that case would be on the fourth quadrant. Now let's look at our question. Our question says we should calculate the value of 12 tan beta. My tan of beta should be replaced by my y over x. Once again, if we were to look at our cos of beta, our cos of beta is actually, I'm going to remove this now because we've already used it. Our cos of beta is actually equal to x over r, to mean that your x there is equal to, guys, is equal to p, and the p is actually divided by 1. So this is the special case I wanted to touch. Your r in that case will be 1. So now let's come to solving for y, because you will need y in order to know the value of 12 tan beta. Once again, using Pythagoras theorem, I'm writing that x squared plus y squared is equal to r squared. What is my x? I said it is p squared. I'm looking for y. What is my r squared? It is 1 squared. Now solving for y, 1 squared is actually 1, and transposing my p squared to that side will be minus p squared. Now if I were to solve my p, add square root both sides, plus or minus, guys, this is what I wanted to talk about. The square on the p will not cancel the square root. Leave it as it is. Look at the sign of your y. How should your y be in the fourth quadrant? It should be negative. So my y there would be negative square root of 1 minus p squared. I wanted to deal with this one that includes square root. So if you were to answer this question, I actually lied. I said I will not answer this question. So my y there is negative of 1 minus p squared under the bracket divided by, what is my x? My x is actually p. So multiplying through it, you'd get negative 2 root 1 plus, sorry, that is actually minus 1 minus p squared divided by the p. So that would be the value you are asked for. Now moving to another thing, guys, I'm thinking this is the last part of this this video. I want to talk about, guys, the special angles. Special angles. We are having the following special angles: 0 or 360 degrees, 30 degrees, 45 degrees, and not lastly 60 degrees, 90 degrees, 180 degrees. Those are your special angles, guys. So for your special angles, it means in any time you are asked to find maybe the sign of any special angle, there's a certain way of writing it. You are told there is a certain triangle, but I'm not going to cover it because it is the same thing. That triangle says a sine of 30 degrees is actually equal to half. So you can actually punch your calculator in order to find the value of this special angle. Say for instance you want to know what is the sine of 0 degrees. According to the curriculum, you are supposed to memorize this. You are supposed to know what is sine of 0, sine of 30, sine of 45, sine of 60 and the rest. You are supposed to know the cos of all those angles. But guys, you do not really have to memorize them. You can simply punch your calculator. Now the one I want to warn you about is that 45 degrees there. When you punch your calculator, it will give you, when you write for instance sine of 45 degrees, it will give you, I'm thinking maybe root 2/2. This is the value of the calculator, but in actual fact the examiners want you to write as 1/√2. 1/√2 is the same as √2/1, but because they will say do not use a calculator. Remember, I'm giving you the tricks here on how to bypass the long process of memorizing all that. So you have to be careful on that specific part. In the place of cos 45, you can punch the rest on the calculator, but when you get to 45, remember to write 1/√2 instead of √2/√2. So the important thing, guys, about these special angles, you have to be able to express an angle when you are given, you have to be able to express an angle. You have to pick at least 2 pairs of these angles that I've written and expressing an angle. How would you do that? Let's make an example. Let's say maybe you are given sine of let me say 175 degrees, and they ask you to express that 175 degrees in terms of one of those special angles. So I can see that my sine of 75 can be written as my sine of my 180 degrees minus 5 degrees. This is what I want you to learn so far, to be able to express an angle in terms of the addition or subtraction of 2 or more angles. To be specific, guys, the number that will always be here at the beginning, it's either it is going to be 180 or 90 degrees or 360 degrees. When, remember this is still the grade 10 and grade 11 revision. When you get to grade 12, you'll be able to pick any pair of your choice. Say you may be able to mix 45 and 30. If you are given sine of 75, you can write it as sine of 30 plus 45. But for now, you are going to have to use the 3. It's either it's 180 plus or minus an angle, 90 degrees plus or minus an angle, 360 degrees plus or minus an angle. So let me make another example. Say for instance I'm given cos of 100 degrees. Cos of 100 degrees in terms of 180 or 90 or 360, my 100 is actually close to 90 degrees. So which angle or which value could I add or subtract from 100 in order for me to have 90? So cos of 100 can be written, guys, as cos of 90 degrees plus 10 degrees. Also making another example, if we are given maybe tan of, let's say, let me say 290. Express 290 in terms of those special angles tan of 290. 290 is actually closer to 360. So in order for you to not sweat, just say 360 minus 290. Whatever answer it will give you, take the 360 and subtract that answer. So for instance, 360 degrees minus 290 is actually 70 degrees. So I can say that I can write my tan of 290 degrees as my tan of 360 and subtract the answer minus 70 degrees. So this is what I want you guys to practice in this video, so that on our next session we begin with our reduction formulae, and finally so we can move to proving identities and simplifying, guys. So please do share the comment, do share the link, guys, for the video, so that others may also be assisted. So this is it for this video, guys. I want you to practice. We are coming with the next session. We are probably going to have 4 or 5, it's a rough estimate of these trigonometric sessions. Remember your trigonometry on your paper 2 weighs for about 55 to 60 marks, guys. 55 to 60 marks. I think it's something around 80% of your paper. So if you can only write this topic, you are assured that you will pass paper 2. So this is it for this video, guys. Thank you for watching. Goodbye.